Autodesk Civil 3D offers corridor modeling capabilities to complete all types of road, rail, and channel design projects more efficiently. This model approach is easy enough for all engineers and technicians to use, yet powerful enough to handle the most complex projects. A corridor model is created from three design elements: an alignment, a profile, and an assembly. An assembly represents the typical cross-section we wish to use for design and is built from intelligent objects called subassemblies, which represent real-world elements like travel lanes, shoulders, ditches, etc. We define the station range that this typical cross-section will be used in, as well as the targets that the assemblies use to lay out the actual design. In this example, the daylight subassemblies need to know what surface to target to create the side slopes of the design. We can see here that the lane elements can be set to follow an alignment for their width and a profile for their outside elevation. This demonstrates the intelligence that can be built into the subassemblies and their ability to transition to alignments and profiles where applicable. The resulting object is a three-dimensional wireframe model that represents our road design. As we look at it in 3D, we see the typical cross-section that was applied, but can also see where the intelligence of the subassemblies come in, where a ditch has been automatically added to areas of cut, and that the side slopes adjust their slope depending on the amount of cut and fill. This is just a small example of the types of conditions that can be accounted for with a powerful modeling technology. Next, we can quickly generate a surface from this model and use it to calculate volumes of cut and fill for the design to see if adjustments are needed. We will use a simple calculator to compare the new surface with the existing ground and get both cut and fill volumes. With this analysis, we can then adjust the design and try to compensate for these volumes and begin to balance them out. The corridor can be rebuilt automatically as changes are made, and in this case, we will adjust the location of a vertical point in the profile and see how it will affect the design. Once the change is made, the corridor rebuilds and the surface updates its contours. We can rerun the volume calculations to see the effect of the change. The corridor model, with its dynamic updating and versatile cross-section design, allows us to explore multiple design scenarios, with the changes we make automatically propagating throughout our design. This allows us to create more accurate designs in less time, saving money and providing a better service to our clients.